So this video is the really last practice for the Chapter 11 test. We're going to have our Chapter 11 test on Tuesday, so you want to study and be ready for that. Okay, so I'm going to be factoring this x squared plus 5x plus 6, and that's going to factor to an x plus 3 and an x plus 2. And then this x squared minus 4, that's a difference of two squares. That's going to be an x plus 2, x minus 2. And so we're trying to get a common denominator for both of these. So from the first fraction, I need to have an x plus 3, and I need to have an x plus 2, okay, from here. And then from the second fraction, I need an x plus 2, but I already have it, so I don't need it again. But I do need an x minus 2. So I'm going to have an x minus 2. So that's going to be my common denominator. So then I need to multiply this side over here by what it's missing, which is this x minus 2. So I'm going to multiply top and bottom by x minus 2. So I'm going to multiply this by x minus 2 and this by x minus 2. And when I do that, x minus 2 times x minus 4, that's going to be an x squared minus 6x plus 8. Okay, because it's what negative 2 and negative 4 add to, which is a negative 6, and multiply 2, which is a positive 8. And for this one over here, this one's missing the x plus 3. So I need to multiply top and bottom by x plus 3. So multiply this by x plus 3, this by x plus 3. And when I multiply these together, x minus 1 times x plus 3 is going to be x squared plus 2x minus 3. And now I'm going to combine like terms, and I'm going to get 2x squared minus 4x plus 5. And I could check to see if this is factorable, but since this is a 5, and a 5 is a 5 and a 1, that's not going to factor to anything that's going to have a 2 or a 3 in it. So we don't need to even try to factor that. And then it's going to be over x plus 3 times x plus 2 times x minus 2. And that's going to be our answer. On number 2, we are multiplying. So we are going to have to factor these. So if I'm focused on this one right here, I'm going to show you how I do it, and then I'm going to do the box and diamond for those of us who maybe feel more comfortable with that. So looking at that, I know that the front 2x squared, the way I can get that, it has to be a 2x and an x. That's the only way to get that. And then the way to get the back, I'm going to be focusing on this, sorry, trying to grab a different color. On this 20, it's a negative 20. I'm just going to jot down the numbers real quick. So that's going to be a 1 and a 20, a 2 and a 10, or a 4 and a 5. And we're trying to get a negative 3, okay, with these. And so when I'm looking at this, whatever comes here is going to multiply with the 2. And whatever's here is just with the 2x. And whatever's here is going to multiply with just the x. So a 20 here, that'd be 20 and a 1 would be too much. That's not going to work. 1 and a 20, that's going to give me a 2 and a 20. That's not going to work. The 2 and the 10. 10 here, that's going to be a 20. 20 and a 2, that's not going to work. If I put the 2 here, that's a 4 and a 10. That's not going to work. So I've got my 4 and my 5. If I put my 5 here, that's a 10 and a 4. Well, that's going to give me a 6, and I'm trying to get a 3. So I'm going to maybe put a 4 here, which gives me an 8, and a 5 here, which gives me a 5. And that's going to be a difference of 3. So that's what I'm going to want. Okay. And then in terms of signs, I'm trying to get a negative 3. So I need this to be my negative 8 with this negative 4 times 2 and a positive 5. Now, if that's not easy for you to see, you can always do the box to diamond. So put your 2x squared here and your negative 20 here. We multiply those together to get a negative 40x squared. And it has to add to that negative 3x we were trying to get before. And that's going to be a negative 8x and a 5x. So I'm going to put in negative 8x and a 5x. And then when I'm trying to find the outside, I'm going to have a 2x and an x. This is going to be a plus 5. This is going to be a minus 4. And you see I got the same answer. Okay. So let me continue doing the rest of this. So on the bottom, the 2x squared minus 7x minus 30, that's going to be a 2x and an x. The 30, let's see, I'm thinking I need a 7. I'm thinking maybe well, if I have a 1 and a 30, a 2 and a 15, a 3 and a 10, and a, let's see, if I do this, if I do, well, the 1 and 30 is definitely not going to work. 2 and 15 don't look like they're going to work. And if I do a 3, let's see. The 3 and the 10 aren't going to work, but I also have a 5 and a 6, right? So I'm thinking 6 here, because that'll give me a 12. And then a 5 here, because that will be a 7. And again, you can do a box to diamond if that's easier for you. This one here, it looks like it might be a perfect square trinomial because I have a square in the front and a square in the back. So if it is, it would be a 2x plus 3, and I'm going to write it as a 2x plus 3, 2x plus 3. The way to check is I've got my 4x squared for sure and my 9 in the back. If I multiply these together, which is a 6, and then double that, which is a 12, that means it's a perfect square. And for the bottom, this is going to be a 2x and an x. I need a 12 and I need to get a 5. So again, we've got 1 and 12, 2 and 6, 3 and 4. And I'm trying to get a 5. I'm thinking 4 here, because that'll be an 8, and 3 here. Okay, so now I need to give restrictions. So my restrictions, x cannot be negative 5 halves, x cannot be 6, x cannot be negative 3 halves, and x cannot be 4. So I have all of those from these, just the denominators. And now let's see if we can simplify. So looking at this, let me just kind of make this a little fainter. This x, 2x plus 5, 2x plus 5, x minus 4, x minus 4, 2x plus 3, 2x plus 3, but I still have a 2x plus 3 left over on top. So it's going to be a 2x plus 3, and then on bottom, an x minus 6, and that's your answer. Okay, so let's take a look at number 3. Okay, so this one is a division. So we are going to factor this. So on top with my 3x squared, that's going to be a 3x and an x. So it could be a 6 and a 2, or a, sorry, 6 and a 1, and or a 3 and a 2. 6 and 1, I don't think will work. 3 and 2, I think this will be a positive 3 because that'll give me a 9, and then the 2. on bottom, 4x squared plus 16x plus 7. That could be a 2x, or it could be a 4x and 1. I'm going to maybe try the 2x because I notice I have a 2x here. So I'm hoping that maybe that will cancel out. Let's see. And I have a 7, which has to be a 7 and 1. So that will give me a 14. And then this will give me a 2. So yeah, that gives me my 16. So that'll be good. Divided by. And now when I'm doing this, that's going to be a 3x and an x. A 2 and a 1. I'm thinking minus 1 here because that'll be a -3, and then plus 2. And then when I'm on this one, again, 2x, x. I need to have a 28. So that's going to be a 7 and a 4. I'm thinking maybe put my +7 here and my 4 here, which will be a -4. That will give me my -8. That will give me a 7. That's going to be a -1. So those are our factors. So now I'm going to give restrictions for on my current denominator. So x cannot be -1/2, -7/2 for these two here. Here, this is also a -7/2. This one here is going to be a 4. But I'm going to be flipping this, flipping this one here, always the one after the division sign. That's the one I'm going to flip. So I'm going to end up with 3x plus 2, x plus 3 over 2x plus 1, 2x plus 7 times, and I'm going to flip it, 2x plus 7, x minus 4, and I get a 3x plus 2 and an x minus 1. So now I have some new denominators. I have this one here, which that cannot be a -2/3, and this one here, which cannot be a 1. So I've got 5 different restrictions for this one. So now I'm going to simplify. And so let's see, 2x plus 7, 2x plus 7, 3x plus 2, 3x plus 2. And that looks like that's it. So my final answer is going to be, on top, I'm going to have an x plus 3 times x minus 4. On bottom, I'm going to have a 2x plus 1 times x minus 1. And that's your answer. So let's take a look at number 4. Okay, so this one's a minus. So what I like to do with my minuses is I do like to change this. I'm going to write it kind of in a fainter writing. So I go like to make this into plus a negative and put parentheses around that. Okay. So this over here is going to be an x minus 2. The other fraction is going to factor to an x plus 6, x minus 2. So when I want a common denominator, I need an x minus 2 from the first one. And from the second one, I need an x plus 6. So my second one has everything from that denominator, okay, because I already had an x minus 2. I didn't need it again. So just this first one here is going to need to be multiplied by an x plus 6 on top and bottom. And so that's going to give me x squared plus 5x minus 6. And then the other fraction, it is a negative that's going to distribute. So I'm going to have a negative x squared, a negative 4x, and a positive 4. And so my x squareds cancel out. I get x minus 2 over x minus 2 times x plus 6. And we actually have some simplifying we can do, because this x minus 2 and this x minus 2 can cancel out. And so my final answer is 1 over x plus 6. Okay, so number 5. We want a fraction best. We want to get rid of an x minus 5, an x, and a 7. So I have to multiply everything by 7x times x minus 5. That's what I'm going to multiply everything by. So let me write this out. Okay, so I'm going to have 3 over x minus 5, and I'm going to write, give myself some space in the front. 2 over x, I'm going to give some space in the back, and 1 over 7. And so everything is going to be multiplied by the 7x times x minus 5. Everything's going to be multiplied by that. So I'm going to copy and paste that. Okay, so everything's going to be multiplied by 7x times x minus 5. And then hopefully everything will have a denominator cancel out. So this and this are going to cancel out. My x and that x are going to cancel out. 7 and 7 are going to cancel out. So I am going to be left with, let's see. Oh, and I have to give my restrictions, but let me just write this out real quick. 21x plus 14 times x minus 5 is equal to x squared minus 5x. Quick little note again, I did not do my restrictions. So x cannot be 5 and 0. This 7's a 7. There's not going to be anything else. So we don't need a restriction for that. Okay, so now when I'm working this out, I'm going to have 21x plus 14x minus 70 is equal to x squared minus 5x. So I'm going to get everything on the same side with my x squared. Okay, so I'm going to have x squared. Over here, this was a 35x, and I'm going to subtract 35x. I'm going to get a negative 40x minus 70. And let's see, this was a negative 70 over here. So this should be a positive 70 when I take it to the other side. So let's see about solving that. It doesn't, I can't think of any factors that are going to multiply to 70 now to negative 40. So what I'm going to do is I'm either going to do quadratic formula or I'm going to complete the square. Okay, so to complete the square, I'm going to bring my 70 over here. And this is going to be x squared minus 40x. And then I can take half of my b, which is negative 20. And then you square that, which is 400. And that's what you need to add to both sides to make it a perfect square. And so I'm going to get 330 is equal to x minus 20 squared. I square root. I get the square root of 330, which is not nice, is equal to x minus 20. Sorry, plus or minus, always plus or minus. And then I'm going to add 20. So I'm going to get 20 plus or minus root 330. And you can put that into your calculator if you want to get decimal approximations. Let's see. So 20 plus the square root of 330 is 38.17. And if I do that as a minus, I get 1.83. And those are your two answers. That's probably a little harder than you're going to see on the test. Yours will probably be solvable. Probably if it's a quadratic, would be factorable, or it's not even going to be a quadratic. Maybe you can have x squared cancel out. That one's a little tougher. You can do that. You can do any of them. Okay, on number 6. So let me just start with my restrictions. So this x plus 2 means x cannot be a -2. And this x minus 1 means x cannot be 1. And I am going to have to multiply by x plus 2 and x minus 1. That's what I'm going to multiply everything by. So I'm going to take x plus 2 times x minus 1 times 1 over x plus 2. Now I'm just going to put that in parentheses. And x plus 2 times x minus 1 times 4x over, and again, I'll put parentheses here, x minus 1, minus 1 times x plus 2 times x minus 1. Okay, so I get all of this. And again, our goal is to have some things cancel out. So this x plus 2 cancel, this x minus 1, this x minus 1, and I am going to end up getting x minus 1 is equal to, when I distribute this, 4x squared plus 8x, and minus, and then I'm going to work this out, put it in parentheses, so that's going to be an x squared plus 1x, or just x minus 2, and then let's distribute. So x minus 1 equals 4x squared plus 8x minus x squared minus x plus 2. And let's clean that up. So 4x squared, 3x squared, and then I am going to have this, which is going to become a minus x over here. So that is going to be a 6x total. And here, this minus 1 is going to become a plus 1 over here. So that is going to give me a plus 3. Everything is divisible by 3. So I'm going to have x squared plus 2x plus 1. And when I factor that, that's going to be x plus 1, or x plus 1 squared. And so my answer is going to be x equal -1. Now that's okay, because up here, it was going to be a positive 1 would be a restriction. So we're good. That's our answer. Okay, on number 7. This one, since we have a 3x, a 6x squared, an 8x, and a 3x squared, my restriction for this is going to be x cannot be 0. That's my restriction. And to get rid of a 3x, a 6x squared, an 8x, and a 3x squared, well, in terms of the numbers, 3, 6, and 8, I'm thinking 24. And in terms of my x and x squared, 24x squared. So we're going to multiply everything by 24x squared. So here, let me do it in blue. So I'm going to multiply this by 24x squared. This by 24x squared. Again, this by, and I'm going to do this plus a negative like that, but this by 24x squared, and this by 24x squared. Let me just move this, my restriction. Let's put my restriction over. I'll put it up here. Okay. So this by 24x squared. And again, hopefully we have things cancel out. So 3 goes into 24 8 times. This x cancels with this, so I don't have that square anymore. X squared all gone. 6 goes into 24 4 times. This x goes into this x squared once, so that square is gone. 8 goes in 24 3 times. X squared gone. 3 goes into 24 8 times. So I am going to get 56x from this. Over here, I'm going to get a 16. Over here, I'm going to get a 5, 3, and x, so 15x. And over here, let's see, I'm going to have a negative 16. And now I'm going to solve this. And I forgot my equal, sorry. This is an equal. Okay, so I'm going to end up subtracting 15x from both sides. And when I do, I get 41x. I'm going to minus 16. Okay, now when I do that, it's gone on this side and I get a negative 32. So I get x is equal to a negative 32 over 41, which is not a restriction, so I'm good to go. Okay, on this one, system. Okay, so for this, we got to figure out if we want to eliminate our x's, our y's, or our z's. And let me label each of these. Let's say that this one here is equation, or let me choose a color, not black. That this one here is equation 1, equation 2, and equation 3. And so I want to get 3 equations with 3 variables down to 2 equations with 2 variables, the same 2 variables. So I'm going to be looking at whether I want to eliminate my x's, my y's, or my z's. So if I am looking at these, my x's, I have a 5x, a 3x, and negative 2x. That's a lot of work to get rid of my x's. I can do it, but I probably don't want to. Over here, if I'm looking at my y's, again, same thing. It's a lot of work to get rid of all of these because each of them has a different number. So maybe I don't want to do that. Again, see all of these different numbers. I'd have to multiply everything. Let's check my z's. So when I have just a plain z, the nice thing about that is I can times it by 3 to get rid of this one. And I can times it by a 5 to get rid of this one. So I think I'm going to do my z's. Okay, that's what I'm going to do. So let's do our z's. So we're going to eliminate z's. Okay, so we focus. Okay, so what I'm going to do is I am going to start with equation 1. Okay, so I'm going to take equation 1, which is 5x plus 6y minus 5z is equal to negative 1. And I am going to multiply equation 3 by a 5 to get rid of my z's. Okay, so let me just write that. So that's going to be a negative 10x plus 25y plus 5z is equal to a negative 20. Okay, so let's see. When I add these together, my x's, I get a negative 5x. I get a 31y. My z's cancel out, and I get a negative 21. So I'm going to call this one equation 4. Okay, so now I'm going to take equation 2. Okay, so I'm going to take equation 2, which is a 3x minus 4y minus 3z equals 7. And I am going to multiply equation 3 to get rid of my z. Okay, over here, my z is a negative 3. I'm going to do it by a positive 3. So I'm going to get, for my new equation 3, a negative 6x plus 15y plus 3z equals negative 12. And I'm going to add these together. So that's going to be a negative 3x and 11y. My z's cancel out, and I get a negative 5. So that'll be equation 5. So now I'm going to take this, and this is what I'm going to solve. So looking at these, my x's and my y's, neither one's super nice, but I think the x's is probably nicer than my y's. So I'm going to try to eliminate my x's. So what I'm going to do is I'm going to try to make these become one of them positive 15, one of them negative 15. So let's say I multiply this one here by let's say 3, and this one here by a negative 5 to make it a positive, okay? So my new equation 4 is going to be a negative 15x plus 63y is equal to a negative hold on, apologize here. This is going to be a 93y is equal to a negative 63. My new equation 5 is going to be a positive 15x minus 55y is equal to a positive 25. When I add that, my x's disappear. And let's see, I end up with a 38y is equal to a negative 38. So as ugly as it looked, I got a nice answer. Y is equal to negative 1. Now, I'm not done solving this system here. Okay, I have not finished solving it. So I'm going to take my y and I'm going to put it into one of my equations 4 or 5. And I'm thinking I'm going to do it into this original 5 here. So I'm going to go negative 3x plus 11 times a negative 1 equals a negative 5. So negative 3x minus 11 equals negative 5. I'm going to add 11. Negative 3x is equal to 6. X is equal to negative 2. So now I can take both of these and put them into either equation 1, 2, or 3. Now I'm trying to solve for z. So I'm thinking I'm going to put it into 3. Okay. So now I'm going to take both of these and put them into equation 3. So I'm going to have negative 2 times negative 2 plus 5 times negative 1 plus z is equal to negative 4. Okay. So that's going to be 4 minus 5 plus z equals negative 4. So negative 1 plus z equals negative 4. And when I add 1, my z is going to be negative 3. So my final answer is going to be negative 2, comma, negative 1, comma, negative 3. That is my final answer. Okay, on the last one, a parabola passing through these points. So let's say equation 1, get a little thicker. Okay, equation 1 is going to be negative 2, comma, 30. Here, I'll just do it color coded. Okay, so negative 2, comma, 31 is going to give me 31 is equal to a times negative 2 squared plus b times negative 2 plus c, which is 31 equals 4a minus 2b plus c. and 4 comma 37. So that's going to be 37 equals A times 4 squared plus B times 4 plus C. So 37 equals 16A plus 4B plus C. And 7 comma 121. 121 equals A times 7 squared plus B times 7 plus C. So 121 is equal to 49A plus 7B plus C. So now I'm going to solve this system. And again, when we're dealing with something like this, we have all of these that have C's. So I can just get rid of my C's in each of these cases, okay? Because trying to deal with an 4A, 16A, and 49A is not going to be nice. Negative 2B, 4B, and 7B aren't going to be nice. But even if they are nice, all of these are C's, and they always will be C's. So I would eliminate C's. So let me just take the first two equations. And let's see. Let's multiply. I think I'm going to multiply the first one by a negative 1. Okay. So I'm going to get a negative 31 is equal to negative 4 plus 2b minus c. And let me add it to my blue equation. So 37 is equal to 16a plus 4b plus c. And I am going to end up getting, let's see, 6, whoops, sorry. I'm going to end up getting 6 is equal to 12a plus 6b. Everything's divisible by 6 if I want. So that's going to be 1 equals 2a plus b. Okay, and I'm going to take that same negative 31 equal negative 4a plus 2b minus c. This time add it to my purple one, which is 121 equals 49a plus 7b plus c. And I am going to get, I'll do it in red. I am going to get let's see, 90 is equal to 45a plus 9b. Everything's divisible by 9, so I'm going to get 10 is equal to 5a plus b. So now I can multiply one of these equations by a negative 1. So I do it to this one, and then I put it down here. So it'll be negative 1 is equal to negative 2a minus b. Add these two equations together. I get 9 is equal to 3a. So a is going to be 3. And I'm thinking I'm going to put that into the orange equation. So in my orange equation, if I plug that in, I'm going to get 1 is equal to 2 times 3 plus b. So 1 is equal to 6 plus b. So b is equal to negative 5. So I've got my a and my b. And I'm thinking c into my pink one. And I'm going to do that. I'll do that over here. Okay. So I'm going to move this a little bit. So 31 is equal to 4 times my a minus 2 times my b plus c. So 31 is equal to 12 plus 10 plus c. So 31 is equal to 22 plus c. So c is going to be equal to a 9. Oops. Sorry. And my last step is to actually write out my equation. Okay. And so my equation is going to be, and here I'm doing it in black, in this green box. So my equation is going to be y equal a, so 3x squared, plus b, so minus 5x, plus c, so plus 9. And that's your equation. So study, study, study. Be ready for our test on Tuesday.